Hey, what's up, guys? So today is the 1st. We have entered June. I got off work, I ate, and here I am. So we're gonna try to get in like an hour. A good hour at least. So I was brainstorming when I was at work about how to fix the issue with what exactly was it? Like how to handle player DCs. So let's see. I'm going to add in this as a trying to think of how to word this specifically. Like, it's for logic whenever, basically it's logic for when player DCs, logic for DC. So anyway, let's see, 6/1/24 is today's date. Create a solid system for handling whenever players DC. Okay, so I figured out at least like principle 1 is that, and that's worded like that. We'll just say like, okay, so when player DCs, threaded client throws exception. Then after the player DCs, the threaded client throws the exception. At this point, this is what we... Yeah, I don't know if those actually might be causing my copyright issues, because I've had like 2 strikes, so I thumbs down those. I'm gonna have to remove them. Anyway, so at this point we want to trigger the main thread to freeze pause. We don't want it to we just basically want it to be locked. Struggling with how to solve this issue. A lock or event maybe, because if we use a lock whenever, like, if we're using a lock, then that means like whenever the player disconnected, the threaded client would have to acquire the lock, and like, I don't know if I can make the other thread release its lock. Like, I don't know how that works exactly. So we'll put could use a lock if the threaded client could cause the see, I don't know, like, I don't know exactly how the logic is with that. Like, if I were to use a lock, and then like have the other thread acquire the lock, like make that first thread release the lock and then the other thread acquire the lock, does that mean that like that other thread pauses at that specific line, and then when it reattains the lock, like does it just continue? You know what I mean? Like, is that how that works? I want to say that is, but I'm really not positive about that. I know that, like, I know generally how locks work, but I'm not, you know, I'm not a professional with them, obviously. So let's see if our like, I know generally how. Okay, there we go. Let's see. All right, let's ask ChatGPT. Python, if I have one thread with an acquired lock and another thread wants, first I'll ask this, wants to acquire the lock, can the other thread we'll just call this one like Y thread. Can the other thread, Y thread, release the lock from the first thread, or does that have to be done by the first thread? Python's threading module, a lock is a synchronization primitive that provides a way for threads to enforce limits on access to a shared resource. If one thread has acquired a lock, another thread wanting to acquire the same lock will be blocked until the first thread releases it. Only the thread that has acquired the lock can release it. The thread attempting to acquire the lock will be blocked until the lock is released by the thread that currently holds it. So in your scenario, the second thread cannot release the lock. The first thread must release the lock itself. Okay, so then my question is, how can I trigger one thread to pause at a specific line and continue after the pause via a triggering event from a second thread? You can achieve this using synchronization primitives provided by Python's threading modules such as event. Here's a basic example, and I was thinking this was probably going to fall into the event category, which I've never used event before. I like know about it somewhat, but I've never used it. Here's a basic example demonstrating how to pause and resume a thread using an event. Okay, so we have pause event equals threading an event, and then we have a thread function which says thread started, thread is waiting to pause, and then pause event wait. So thread waits until pause event is set. So, and then we have the main, which is thread equals thread.threading target thread function, and then we have thread start. Input, press enter to pause the thread, and then set the pause event to pause the thread. So now we have pause event dot set. So now that this one is set, the thread is so once we set this event, then it's gonna continue. I thought, like, oh no, then you have to clear it. Okay, so then input, press enter to resume the thread, and then pause event clear the pause event to resume the thread, and then thread join. Okay, so the issue with this is that, like, it's not going to, that means that I would constantly be having to check, like, I would have to have, like, pause event dot wait, you know, after like every line of code. You know what I'm saying? So, like, that just seems absolutely insane to, you know, because well, no, that's not true actually. See, because the game is so complex in progression that, like, some of these functions get so, like, there's such a trail, you know what I mean, like a progression from this function to that function to this function, depending on the choices that the player makes, to where, like, to somehow not just pause exactly where it is, and then to, like, re-enter, like, some sort of special, you know, logic to get exactly back to the point that it was, it's just unreasonable. Like, it's just crazy. Like, that I am not doing that. If that's what's required, then we're just not gonna have that. I think that there's probably a type of workaround where basically, like, I was thinking about this, is what if we just allowed the game, like, to pause it, the main thread to pause itself, basically, because the main thread always ends up waiting on player input. At a certain point, it's not gonna continue, you know, like, it's gonna hit this while loop, it's gonna change its progression text, and it's gonna have this multiple choice yes or no, and, like, at this point, this is gonna cause a while loop to begin on the main thread, and this while loop is just gonna continue forever until the player makes their choice. So this is, like, basically the game pausing itself. So, like, I guess you could say that we already have this in place, a system to pause the game, like pausing. Although it's not actually pausing the game, like it's not an immediate freeze. I think that because we would, let's see, and I was thinking about this earlier as well, if the threaded client could cause the, yeah, I don't think we could use a lock. After further thought, I don't think we could use a lock or an event. It would require addition of a lot of logic, like not doing it. Not doing it, guys. I'm so done with this project. I am not doing that. Anyway, player DC's threaded client throws exception. So here's the other option. Say other option is to allow main thread to pause itself naturally via prog pies, while loops, etc. Well, just not etc. Just the while loops, because that's literally it. It's just the while loops. There's not an etc. There's just that. So that's one way, and using this option, what would happen is the main thread may continue to process a bit of data after player DCs, but that data will like, and we'll just put this data needs to end up in proper change attribute list. So that's what has to happen, is the data needs to end up in the proper change attribute list. Okay, fair enough. Now, how is that going to be accomplished? So like normally this happens. Well, no, actually it already does, right? Because this already happens. Because whenever data point change is made in main thread, the data is added to associated change attribute list. Yeah, so that's definitely already taken care of, I'm pretty certain. So like this main thread append, and then we can just get rid of this line, and then we'll so whenever player reconnects the client thread will detect the populated change attribute list and send it as usual, and it's ready. Now, okay, so now in the case that the client may not have received some already sent data, like prior to the data processed after the DC, the receive verify system would ensure that we resend any lost data before sending the or actually, like, we could still send it, it just wouldn't apply it, right? It would just be another packet. And even if we even if we sent that, like, the packet that containing, you know, this data first, or this data, the data that was processed after the player DCs, it creates like a new custom append list, you know, population, or change attribute list, not custom append list, change attribute list population. And then when the client reconnects, that thread starts running again, which transmits all the data and sees that populated change attribute list, sends it. But then when the client receives it, it's not going to apply the data, because that's not going to be like the apply counter value is not going to be next in line. So that's going to stop it from doing that. So I think this system actually sounds like pretty good. Yeah, I mean, that actually sounds pretty good to me. We don't that doesn't require us to add any logic. It just, like, not to refactor, rather. We don't have to refactor anything. We just have to add in the logic, obviously for the receive verify that we haven't finished yet, and also for the receive order integrity. Those two systems would have to be in place first, but then after that, this should be able to ensure that the player at least from the server side would be back up to speed. They would reconnect, and upon reconnecting, we would just basically just send data as usual. Like, there wouldn't, and nothing special would have to happen on the server side. We would basically just send the data as usual, and the client side is going to handle, or the receiving side is going to handle the data application to make sure it gets applied in the correct order. And the receive verify system on the client side is going to ensure that the client gets resent any data that it lost, that was sent but was never actually processed, on the received, rather, on the client side. So I think this sounds like a solid system to me. So the main thread pauses itself naturally via progression while loops. The main thread will continue to process a bit of data until it hits, like, and we'll put until it hits next while loop, waiting on player input. And this data will end up in, ends up in proper change attribute list via main thread change attribute list. Where do you write that? Via main thread append. Now, whenever player reconnects, the client thread will detect the populated change attribute list and send it as usual when it's ready. That's true. And then now, in the case that the client may not have received some already sent data, Um, Now, one thing that we do need to take care of is the fact that the main thread continued to process a bit of data after the player DCs. We may have to modify the logic in ProgPy to ensure like that it properly pauses and doesn't just pause briefly, like for 2 seconds, because then the client will have missed out on progression, on game progression. So this would entail things like entails things such as like enter, continue, display, etc. Like some of that stuff is like on a timer, and we would obviously like want to just change that to where this would accommodate the disconnect system, which, you know, we don't ever want to just assume that the player has read it. We want to make sure that their input is what progresses to the next stage. Requires ensuring player input from client side always determines game progression, not timers, etc. Okay. Now, whenever the player reconnects, the client thread will detect the populated change attribute list and will send it as usual. Correct. Yeah, I don't see any issue with that. Now, in the case that the client may not have received some already sent data prior to the data process after the DC, verify system would ensure that we resend any lost data before sending, or we would resend. Sure that we would resend any lost data, and the client would ensure not applying out of order data based on apply counter system. So the last thing that we have to figure out is the let me see. So then it's really got to. Alright. Option 1 allow main third deposit not to be recorded. And then whenever, okay, so what if it's the other client's turn? What if, okay, that's something we need to ask. Okay, but what about if it, what about when the other client DCs? And then also it's how to restore client game state, entire game state. Okay, so whenever the other client DCs, like whenever the other client DCs concerning whose turn it is, like whenever it's the other client's turn, then that means like the client that disconnected, it's not their turn, so the other client just continues to make their play, Um, I guess what would happen is I think we would need to immediately pause the client the client whose turn it is in this case. Would entail sending other clients DC message and entering a while loop, I suppose. And this would ensure the DC'd client doesn't miss other players' game progression or choices, which could really mess them up as far as, like, you know, what decisions they make and stuff. So yeah, I think that's a pretty good system, actually. I was like getting anxiety trying to figure out a solution to that problem. I was thinking, like, oh my god, this sounds so bad, so terrible. And something I've learned in programming, that it's kind of like this paradox or whatever you want to call it, is that issues are usually way more complicated than they seem at first, but also a lot less difficult than you might think. So although things may be more complex overall than you might initially expect them to be, whenever you break those issues down into smaller little problems, then you no longer, like, although you had more problems than you thought you were going to have, those problems are more easily solved than you thought they would be. So, you know, it kind of like evens itself out to where it ends up being more complicated, but when you break those problems down into little pieces, it's like, okay, this actually isn't as hard as I thought it was going to be. So let's look at this. Well, we already did. I think this is really good. Main thread making data process bit data when our player reconnects. Alright, they will detect by player turn and send as usual when it's ready. What about when the other client DC? We need to pause the client immediately. Pause the client whose turn it is in this case. Would entail sending other client DC message entering while loop, I suppose. And this will ensure the DC client doesn't miss. Okay, but how does that work? Well, that works like for the main thread, because the client thread is basically like pausing itself. So since the other client thread is like pausing itself, then the main thread is like naturally pausing while it's waiting on that client's input. So yeah, I think that solves the entire issue. So the problem we have now is, how do we restore the game state of the player who disconnected? And this would either be done from server side or client side. Client side would mean cache or saving to file, and server side would obviously involve data transmission. Client side would not involve data transmission, and I have to use the restroom. I'll be back in just a second. Okay, so I am back. Let's see what we got going on here. Alright, yeah, so we got this system figured out, except for restoring the client's entire game state. And this indeed is this is a little tricky. Like, so when a player disconnects on the client side, if we were to just make a save to a file after every single data change, we would basically just store, like, we would store everything like we wouldn't have to, I was thinking, we wouldn't have to re-save every single thing. We would only have to re-save like each aspect of it, like through like a dictionary. So let's say we have a file that basically just has a dictionary which contains the data for every transferred data point. So like, well, no, not every transferred. It would have to be like literally every data point. So that whenever the client reconnected, we would have to reassign, like, because they would be recreating the they would be recreating the state of the game prior to the disconnect. So my concern is about certain like details, like prior card group name or prior meld num. But as long as we saved the exact state of everything whenever the client reconnected, it would obviously have to run, it would have to run like setup. It would still have to run the, so let's go to client and let's just get a glimpse of what exactly happens when it reconnects. So when it reconnects, it's going to and this needs to be updated. Put notes 6.24. This needs to be updated to reflect apply counter changes, etc. Okay, now we don't need to look at dir check. So if name is equal to main, it's going to try, so it's going to connect. The client ID is going to be set to none. While client ID is set to none, it's going to it's gonna say if client ID is equal to 1, current client ID. Okay, so wait, in this case though, if client 1 was the one that disconnected, okay, so in this case, if it was a DC, then we wouldn't want this game state or progression text to be printed. We would just say, so like this would be if other client dot online is equal to false. So only then would we do this. So this would actually go down here under other client. Is it raining? It's raining? Oh, that sucks. I totally want to go to the skate park. Damn. Oh, and it's raining like hard as fuck too. Oh no. That sucks. Damn. I like so wanted to go to the skate park. Bummer, dude. Oh well. Boohoo. Okay. Well. Anyway. Okay, so we're at 45. I'm gonna go 15 more minutes, then we're gonna quit. I'm gonna go to the gym, and then I'm gonna eat my dinner after. Yeah, I think that this line should be added. So we'll put below line or added, created, whatever, added 6/124. Added this for in whenever a player is reconnecting. The other client is already online. We know this is a reconnect, and we're not actually waiting for the other player. Yeah, pretty simple, straightforward there. Okay. Now, what's gonna happen after this is, let's see. It's equal to true. Online is equal to true. It should be equal to false. Yeah, so that's correct, I believe. Okay, so then we set Pygame video mode, and then we would run setup. So let's go to setup and see what happens here. So in setup, this is where we assign all the custom append list instances, and yeah, I'm like, this would, you know, I'm pretty sure like this would see, but then yeah, but then we would be creating the deck again. and shuffling the deck and then recreating the master deck. Yeah, we don't actually want this stuff to happen again. Like, we would have to, we couldn't just one-to-one run the same like section of code that is run whenever a player initially connects as when they reconnect. When they reconnect, it's gonna have to be different. It's gonna have to be something different. Yeah, I don't think there's a way around that. Which, so basically, like, I think basically we would have to add in special logic server side and client side for a reconnect. So let's write this down. Okay, so I'll put, let's see. First of all, special logic will be needed for server side and client side. So server side, we want to avoid like what certain application of certain data. But then client side, I can be more specific because I know exactly what. So bypass running setup function, and also the while client ID equals none section. While client ID is equal to none section. If we reran setup, then we would be recreating the master deck, etc. A better option would be to simply use the save file to store all of this data. Yeah, so basically we could so yeah, we would add in basically a line up here that says, like, you'd have to have some way to say, hey, this is a reconnect. Add logic which detects if this is a reconnect. If so, we might execute lines number 32 all the way to well, even 366, because we might have a populated ink timestamp list. 366. instead apply data from save file. So basically this would say if reconnect true is equal to false, because that's going to be the more common option, then do all this. But then we put if reconnect is equal to true, then we'll say if reconnect is equal to true, store data from save file. I think that's a pretty solid solution. Okay. I'm not sure. I'm not sure we could use a cache in this case. Wouldn't the duration of a cache be limited to exclude using this, since we would need persistent stored data over a possibly long period of time? And then saving the file seems like the better option, since we need a long running data storage mechanism. Okay. So ChatGPT, let's ask when the duration of cache be limited to exclude using. Wouldn't the duration of a cache being time limited exclude being able to use one, since we would need persistent stored data over a possibly long period of time? Wouldn't we need to use a file instead of a cache? Yes, you're correct. If you need persistent storage of data over a potentially long period of time, using a cache with a time limit might not be suitable. Caches are typically used for temporary storage of frequently accessed data to improve performance. They are not designed for long-term storage or data persistence. In such cases, using a file or a database would be more appropriate for storing data persistently. So database. See, now this is something that I have not considered. I mean, probably not a database. Like, I would probably use a database for like scoring or something like that, but like not for this. I think like a local file would probably be the better option. In such cases, basically like when you're playing a game and you have like that setup config file that like even if your game crashes or whatever, like when you save your settings and then you restore the game, your settings are always like the same. Unless you were to like delete that setup file and then they would be like set back to default settings. So in such cases, using a file database would be more appropriate for storing data persistently. Files offer a simple and straightforward way to store data on a disk, and I actually don't really use files much, so like this would be a good part of my portfolio and learning process is like using and accessing files, which is, you know, probably very important and would be used a lot in actual like software engineering. So while databases provide more advanced features like querying, indexing, and transactions, yeah, we don't need to do all that. You can use file operations in Pythons to read from and write to files. Here's a basic example. Writing data to a file. With open data.txt ws file.write hello world. Okay. With open data.txt r as file, data equals file.read. And then like basically we would go through each, like we would basically have to reapply or reassign like every single value. Yeah, like I don't really see a way around that. Obviously that would have to be done. So basically our save file structure. So I think what we're gonna do is we're gonna go with the save file, and now we have to figure out like our save file structure. What is our save file structure, etc. So this example writes a string if your data is more complex or requires querying and indexing, you might consider using a database like SQLite, MySQL, or PostgreSQL. Yeah, so file I think is the way to go. So we're gonna go with file. We're not gonna use a cache. No cache. Okay. Seems like the better option is to need a long-running data storage mechanism. Okay. What will be the structure of the file? Would need to assign every single attribute, value, etc. Throughout every single file. So this would entail a structure that like basically could use a for loop over dictionaries. And we say each dict represents a file. Each key represents the attr value, and then each value represents the attr value data to be assigned. And we would probably have to ensure proper ordering of file data assignment for proper functionality. Like, you know, like assigning like player before deck. Something like that. Okay. Yeah, so I think that's pretty good. I think we have a pretty solid system figured out here. Um, yeah, this is good. So we actually, I'm pretty confident on these. Like this, we have to do this one. We can't do two until we do one, etc. Well, I don't know if this was actually one or two. I have to figure that out. One or two, I don't know. And then logic for DC is definitely gonna have to be number 3. Yeah, because that relies on receive verification and receive order integrity. And then the Sturlock's ring race conditions, yeah, we definitely should still make the final review for race conditions. Okay, so we're gonna go ahead and stop there, and we can close all these files. And oh shit, which file was that? Didn't I? Well, that's fine. It'll show itself. We'll just put 371 in clients where we stopped. Finished creating final pass, I believe, for receive, verify, order integrity, apply order integrity, and player DC reconnect issues. Final pass, outline, brainstorm. Yeah. And then I'll put begin applying code for this. Okay, and now we're going to stage, commit, and push our changes. So this is going to be our commit message. So we are in the root directory, so now we're going to do git branch to ensure that we are on the correct branch, which we are. And we're also in the root project directory. So now we do git add dot, which is going to add everything. We can ignore those LF warnings. We can do git commit -m, and wow, no apostrophes, huh? So we did 22 files changed, 1183 insertions, 117 deletions. So all those lines are coming from creating the server refactor and the client refactor. And I want to put like ensure to work in server client refactor and not actual server client. Yeah, and that is true. It's just safer that way. And then we'll do git push canasta secondary. There we go. Okay, so now we need to just do our local backup. So we'll go to programming projects canasta. We'll copy current, go back out to the backup and go to the backup, go to this notification, paste in the new backup, go into it and check to ensure that the devlog reflects today's date, which it does. 6/1/24, that's today. So now we go out to the folder and change the name to reflect today's date, which is going to be 6/1/24, and